Okay, we're jumping into section 2 of chapter 5, properties of rational exponents and radicals. So let's just jump right into it. So exploration 1, you're going to work with a partner or by yourself. It says let A and B be real numbers. Use the properties of exponents to complete each statement, then match each completed statement with the property it illustrates. So I'll do letter A with you to show you what I want you to do, because my other class was kind of confused when I just told them to do it on their own. So this is like a review of our properties that you learned in Algebra 1. If you're in my class, you did learn these, believe it or not, whether you remember them or not. But we did go over these. So letter A, I have A to the negative 2 power. And it wants me to complete that statement. Does anyone remember how to handle negative exponents? You don't necessarily flip it. A lot of people get that confused. You just change its position in the fraction, though. Yeah. So if it's over 1, it looks like you're flipping it, but you're really not.
Sometimes remember you taught it with like neighbors or something?
It's like one.
Do what?
Didn't you teach this one with like neighbors or something? Like neighbors and whatever?
I don't think I taught it like that. You may have heard that from someone else. But if I have A to the negative 2, that's technically over 1, right? If it was in fraction form. So I change the thing that has the negative exponent, I change its position in the fraction. So it comes downstairs and becomes positive, and I'd be left with a 1 upstairs. So that would what I'd put on my blank. 1 over A squared. Sorry if you can't read that. I'll fix it. 1 over A squared. So that's what it means by completing the statement. I want you to tell you what it equals. And then which property would this be? Of those over to the right. Negative exponent, so I'd write D next to it. So that's what you're doing on those. So either work with a partner or work by yourself. If you can't read these, just ask and I can clarify what they are for you. Can everyone kind of read the exponents, or are they too small? Too small. Okay. So for B, we have A times B to the 4th power. Is that better?
You didn't do anything. Oh, never mind. I didn't see you draw it.
For letter C, I have A to the 3rd power to the 4th power. D, I have A to the 3rd times A to the 4th. E, I have A over B cubed. F, I have A to the 6th over A squared. And G, I have A to the 0. Is that a little better? Can you read those a little better? Okay, so like I said, you're either working with a partner or on your own to complete the statement and then match the property with it. Okay? So
What is G? A to the what?
0. A to the 0 power. If you need to, think about what the expanded form of it would be if you wrote it out instead of using exponents. So AB to the 4th would be AB times AB times AB times AB. See if you could figure it out from that, if you can't figure it out otherwise. All right. So did anyone get letter B? AB to the 4th. What would that equal? Very good. A to the 4th times B to the 4th. Like I said, if you write it expanded out, it's AB times AB times AB times AB. So multiplying all those, A times A times A times A gives me A to the 4th. B times B times B times B gives me B to the 4th, correct? So a little kind of trick. In the parentheses, what are A and B's understood exponents? 1. So we can multiply each exponent inside the parentheses by the exponent outside the parentheses. So 1 times 4 is 4. 1 times 4 is 4. So A to the 4th, B to the 4th. Everyone see that for letter B. Which property is this?
Power of product.
Power of a product.
Oh, wow.
Because I have a product, the product is A times B raised to a power. So it's a power of a product. Does that make sense? Okay, letter C. Knowing what we know for letter B, what do I do on letter C?
You that another exponent, isn't it? It's like one of those. Like one of those.
Do what?
Is it like one of those? Letter A is letter C, kind of like A.
Not like the A. It's more like this right here. Yep. I've got a power raised to a power. So every exponent in parentheses gets multiplied by the exponent outside the parentheses. So what's 3 times 4? A to the 12th. Everyone good there? That one you could have expanded out also. A to the 3rd times A to the 3rd times A to the 3rd times A to the 3rd. Then you could have expanded each one of those out. You'd have been left with 12 A's. So A to the 12th. Which property is this?
Power of power.
Power of a power. B. I've got a power, A to the 3rd, raised to another power to the 4th power. Questions on C? Okay, letter D. A to the 3rd times A to the 4th. How would I go about this one? I add the exponents. If I'm multiplying something with the same base, my base is A, I can add their exponents. And here's why. Like I said, let's expand it out. If I have A to the 3rd, that's A times A times A times A times A to the 4th would be A times A times A times A. How many total A's do I have there? 7. So that's why I'm able to just add my exponents if I have the same base. Any questions there? Which property is this? Product of powers, which is A. I've got 2 powers being multiplied by each other. Questions on D? Letter E. I have A over B to the 3rd. Any ideas how I'm going to go about that?
A squared or A cubed over B.
Very good. A cubed over B cubed. If I wrote that out, expanded it out, it'd be A times B, or A over B, times A over B, times A over B. A times A times A gives me A to the 3rd. B times B times B gives me B to the 3rd. Questions on E? Which property is it? Power of a quotient. Because I have a division problem, A over B, got a quotient going on, raised to a power. That makes sense?
So it's the power of a quotient.
Do what?
That's G.
Yep, G, power of a quotient. Do what? Okay. Okay, letter F. A to the 6th over A squared. Anyone have any ideas how to approach this one? Very good. Subtract 6 and 2. What's 6 minus 2? Here's how we're able to do this. If I expand A to the 6th out, and I expand a squared out, what's going to happen with some of my a's?
They're gonna cancel out.
2 of my a's in the numerator are going to cancel out with the 2 a's in the denominator. I'm left with 4 a's in the numerator. So that'd be a to the 4th over 1, or just a to the 4th. That's why we're able to do that. Let's say it was flipped and it was a squared over a to the 6th. I would still have 2 a's that cancel out, but where's my 4 a's left now? It'd be 1 over a to the 4th. So if we have a to the 2 over 6, we could do a to the 2 minus 6. We always do top exponent minus bottom exponent. So if a squared was up top, a to the 6 was in the bottom, this is what it would look like. What's 2 minus 6? Negative 4. Then how do I handle a negative exponent? Change its position in the fraction. So that's how that works out. Everyone see that? If you're dividing something with the same base, subtract the exponents, top minus bottom. If you're multiplying something with the same base, add the exponents. So which property is this one? Quotient of powers, which is F. And then letter G, which property is that, Colby?
Zero exponent.
Very good.
Good job, guys.
Okay, a to the 0 power equals what? Not 0. 1. Anything to the 0 power equals 1. If I have 5,793,267 raised to the 0 power, the answer is 1. Okay? Any questions on any of these?
Nope.
Not too terrible? Does it somewhat ring some bells from Algebra 1?
No.
To some of us at least?
The only one was like the one we had to like cross out the ones.
Cross out the what?
The power level quotient. That's the
Okay.
only one I did.
Gotcha.
Zero exponents don't ever ring together.
I do
Okay.
remember how to do it.
Well, did it make sense when I went through it?
Yeah.
What we can do with them? Okay. Show that you can apply the properties of integer exponents, which is what we just went over, to rational exponents by simplifying each expression. So once again, let's work with a partner or by yourself to simplify each of these expressions. We are staying in our seats. We're not moving seats. We're not just getting out of our seat to go to the next seat next to us. We're staying in our seats. Okay? So go ahead and work on this for a little bit using the properties we just used. So, letter A. I have 5 to the 2/3 times 5 to the 4/3. I'm multiplying something with the same base. So what can I do? Add the exponents. So 2/3 plus 4/3. When I'm adding fractions, I need a common denominator. Do I have a common denominator here?
Yes.
Yep. So how can I add my fractions? Do I add the top numbers together and the bottom numbers together?
No, just add the top.
Just add the top, keep the denominator the same. What's 2 plus 4? And then I have 3. What's 6 divided by 3? 2. What's 5 squared? 25.
So where does the other 5 go?
So there's letter A. Do what?
So the other 5 goes.
We combine them together.
Okay.
Whenever, that's what we did when we added the exponents. 5 to the 2/3 times 5 to the 4/3 just became 5 squared together. Does that make sense? Questions on A?
So we're doing all of them?
Do y'all want to go ahead and try them on your own, or do you want me to keep going through them with y'all?
You can keep going.
Okay. I have 3 to the 1/5 for letter B times 3 to 4/5. Same concept as letter A. Multiplying two things with the same base. So what do?
Yeah, I don't know.
So 3 to the 1/5 plus 4/5. What's 1/5 plus 4/5? 5/5. What's 5 divided by 5? 1. What's 3 to the first power? There's letter B. Questions on B? Letter C. We have 4 to the 2/3 cubed. What do I do if I have a power raised to a power?
Distribute the power to the power.
Multiply the exponents. So multiply 2/3 times 3. What is 2/3 times 3? Or what is 2/3 of 3? 2. So I get 4 squared, which is 16. There's letter C. For not knowing what?
For just not knowing.
The rules of the exponents?
Yeah.
Oh. It's alright, we're reviewing them. Letter D. 10 to the 1/2 to the 4th power. Same concept as C. What's 4 times 1/2? 2. What is 10 squared? 100. Questions on D? Power to a power, multiply the exponents. Multiplying something with the same base, add the exponents. Letter E. I have 8 to the 5/2 over 8 to the 1/2. We're dividing something with the same base, so we subtract the exponents. So what is 5/2 minus 1/2? 4/2. What's 4 divided by 2? 8 squared. Not too shabby. F. We have 7 to the 2/3 over 7 to the 5/3. Yes. Me too. Okay, what do we do on letter F?
We have to subtract.
Subtract them. Top minus bottom, right? So what minus what? 2/3 minus 5/3. What is 2/3 minus 5/3?
Negative 3 over 3.
Negative 3/3. What is negative 3 divided by 3? Negative 1. How do I handle a negative exponent? Change its position in the fraction. Don't say flip it. Quit saying flip it. We don't just flip the fraction. We just change the thing that has the negative exponent's position in the fraction.
Okay, but since it's a 1, wouldn't it like just go away?
Say it again.
Since it's a 1, wouldn't it just go away?
Yep. The 1 exponent would. You don't have to write it with the 1 exponent. It's still understood to be there, though.
How is that not flipping it though?
So, that's a good question.
Because
Okay.
you know
So,
the ones that
if...
at the bottom to begin with, so you're not
Hold on one second. Hold on.
adding.
So if I have x to the negative 3rd over 1, I'm changing its position in the fraction. Okay? So that 1 in the denominator stays there when the x to the 3rd comes down. I've got to have something in the numerator, though. What's understood to be in front of this x to the negative 3rd? 1. That 1 stays there. So that's why it's 1 over x to the 3rd. If I have 2x to the negative 5th, I don't bring 2 down with x to the negative 5th. That's why I say change its position in the fraction. I'm not just flipping it. Does that make sense? Or if I have x to the negative 5th over 3, I'm not flipping that. That 3 has to stay downstairs. You're just changing the thing that has the negative exponent. You're changing its position in the fraction. Is that a good explanation? Did that help? Okay. Questions on any of these problems we just went over? Good? All right, here we go. With a partner or by yourself, or I may just start going over them with you guys. Use the properties of exponents to write each expression as a single radical. So the first thing we're going to do, we're going to take our problem, write it with one radical. Then we're going to evaluate the expression. Yes? Not right now.
We're just getting to the good part.
So, letter A. I have the square root of 3 times the square root of 12. We kind of covered this whenever we were doing our dividing radicals and we were multiplying to get the radical out of the denominator. So, if I'm multiplying radicals, you guys remember what we did on that those worksheets. If we're multiplying radicals, what do we do?
You find 3 times 12.
Very good. So letter A, I have the square root of 3 times the square root of 12. I can just multiply those two numbers that are under the radical. So what is 3 times 12? 36. We also have done the reverse of this to simplify our radicals. Do you guys remember that? We found the biggest perfect square that went into our number, and we broke it down into two numbers, and then we broke them down into their own square roots. Does that make sense? So you can work this way, or you can work this way. What is the square root of 36? 6. There we go. Questions there? So letter B, instead of square roots, we have cube roots. Do you think the concept changes though? No. As long as my root matches up, like I have a cube root times a cube root, square root times a square root, I can multiply those numbers under the radical all day long. So what is 5 times 25? 125. Cube root of that is 5. I'm asking myself what number times itself gives me 125? That is 5. Questions on B? Letter C. 4th root of 27 times the 4th root of 3. Do the roots match up? Yep, so what can I do with those numbers under the roots? Multiply them. What's 27 times 3? 81. So now I'm asking myself what number times itself gives me 81. What is it? It is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Questions on C? D. Square root of 98 over square root of 2. Knowing what I know from A, B, and C, what do you think we're going to do with letter D? Divide. I can write this as one radical, as the square root of 98 over 2. What is the square root of 90, or what is 98 divided by 2? 49. 98 divided by 2, yep. Does everyone see that? Once again, you can work either way on this. You can break it down like this, or you can put it together like this. Square root of 49 is 7. Questions on D? Not too terrible? Letter E. Fourth root of 4 over the 4th root of 1024. Once again, we're dividing with the same root, so we can put them under one radical. What does 4 over 1024 reduce down to? One over 256. So I'm asking myself what number times itself times itself times itself gives me 1 over 256. Do what? What'd you say? 1/4. Questions on E? Last one on this page.
How many more of these do we have?
Who knows?
Class is about to be over.
It's okay.
Yeah, we have 9 minutes and I need.
F, we have the cube root. 625 over the cube root of 5. Same concept we've been doing. We can write it under one radical. What is 625 divided by 5? 125. And we already did this one. What's the cube root of 125? 5. Questions on F? So once again, if you're multiplying two radicals, they have the same root, you can multiply the two numbers under that radical. If you're dividing two radicals, you can divide the numbers under the radicals. Okay? Any questions on that? Not too terrible? Good little review for today? Can I go ahead and move on? Are we still writing, or am I good to move on? All right. So here's our properties of our rational exponents. We kind of covered those already. You'll probably want to write this down, though, but we'll do that on Thursday. Any questions before I end my recording?